So let's make sure we're going to take a look at some examples of how we can use our new distance formula, just to kind of get a feel for how it works and the sort of things we can do with it. So just by way of review, I've got the formula here, right? To find the distance between 2 points. The way I remember this, I you find the difference of the x coordinates, the difference of the y coordinates, you square each one, add them together, take the square root. And so let's see what we can do with this formula. So I've got a question for us to start with here. I want to find all the points that are 3 units from the point 3 comma 2 and that are on that line. All right, so I've got a graph over here so we can sketch a quick picture, see what we're talking about. There's my point, right, over 3 up 2, and there's my line, x equals 4. So somewhere on this line, there is a point, at least one point, that is exactly 3 units from the one we were given, and I'd like to find its coordinates. Okay, so the first thing I'm going to do is I'm going to say, look, I don't know what the y coordinate of this point is. Because it's on that line x equals 4, I do know its x coordinate. So the coordinate of this point, whatever it is 4 comma y. So all I really have to do is find the y value. All right, so I'm going to take 4 comma y and 3 comma 2, and I'm going to put those numbers into our distance formula. So it'll be 3 minus 4 squared plus y minus 2 squared. The square root of that whole thing is equal to the distance, and the question says that's 3 units. Okay, great. Now I've got an equation, right? All I need to do is solve this for y. So first I'm going to simplify inside that square root. 3 minus 4 is negative 1. Negative 1 squared is positive 1. So this is the square root of 1 plus y minus 2 squared. That equals 3. So let's see, next square both sides. 1 plus y minus 2 squared equals 9. Subtract 1, y minus 2 squared equals 8. And now this is a point where I see students get into a little trouble sometimes. They say, okay, well, look, I know this is going to be a quadratic thing because it's going to have a y squared in it. So they multiply that y minus 2 out. They set it equal to 0. Then it's a quadratic formula. And there's a lot of work to be done. The shorter path is to just say, look, let's take the square root of both sides. The square root of the left side is y minus 2. And the square root of the right side is, because we're solving an equation, plus or minus the square root of 8. I add 2 to both sides and we're home free. Y equals 2 plus or minus. So we can simplify that square root of 8, right? That's 2 square roots of 2. Now, be careful, because that's not the answer, right? What did the question ask for? The question asked for points. So my answer should be the coordinates of points. So my answer is the points on that line that are 3 units from 3 comma 2 are going to be 4 comma 2 plus or minus 2 square roots of 2. So yeah, there are 2, and that makes sense, right? Because there's a point up here above the given point, and yeah, there's going to be a point down here below it also. So there's 2 answers. So I've got another question here. This time something a little more geometry related. We're given 2 vertices of an equilateral triangle. So that's going to be, go ahead and graph them. That's going to be right there. And we want to find the possible values of the third vertex. Okay. I don't know where it's going to be. There's going to be one out there in the first quadrant somewhere. Right, so I'm going to kind of just sketch in the other 2 sides, more or less where they're going to be. All right, now one other thing I know is I know the length of these sides. Remember, equilateral triangle, they're all going to be the same. The length of that side on the y-axis there, that's going to be 6 units. Okay, so there's 2 ways I could kind of approach this from here. One way would be to just call this point here x comma y. Then I can find the distance from that point to this one, use my formula, set it equal to 6. Now that's good. That equation is going to have 2 variables in it. Right, so then I could also do it again down here. With that point, I'm going to get a second equation with two variables. Now I've got a system of equations in two variables, and yeah, I should be able to solve that. But that's kind of the long way around. Right? We can actually do this a little simpler if we just pull out a little geometry. I'm going to draw a perpendicular line from that vertex that I'm trying to find over to the y-axis. Now, I drew that line so it was perpendicular. And because this is an equilateral triangle, right, I know that that perpendicular is going to bisect that side, which means this section down here is going to be 3, which means the y-coordinate of this point over here is going to be 4. Okay, that helps me out, right? That helps me out because now I'm going to pick one of these points. I'm going to use the bottom point down here for no other reason than its numbers are a little smaller, and I'm hoping that's going to make things a little easier for me. And I'm going to use the distance formula between that point and my x comma 4 point. Right, so if I do that, I get x minus 0 squared plus 4 minus 1 squared. The square root of that has to equal 6. Okay, great. Now one equation, one variable. This one I should be able to solve without a whole lot of trouble. 4 minus 1 squared is 3. 3 squared is 9. So this is the square root of x squared plus 9 equals 6. We'll square both sides. X squared plus 9 equals 36. X equals 36 minus 9. That's 27. Excuse me, x squared equals that. So x equals plus or minus square root of 27, which is 3 times the square root of 3, right? So those are going to be my x coordinates. Yeah, we did come up with two answers, right? There's going to be a point over here in the first quadrant, and there's going to be a corresponding point over here in the second quadrant, right? So the answer to the question here, right? Find the possible coordinates of the third vertex. Is going to be plus or minus 3 square root of 3, comma 4. Right, so I've got one more question for us here to look at. This is kind of a practical one taken from user interface design. I'm assuming everybody here has used a computer. You know, if you move the mouse around, when you get near certain points, like a hyperlink, for example, or the edge of a window where you can resize it, the cursor changes shape to indicate that you're in a place where you can maybe do something. And the way it works with this particular example here is if the mouse, the mouse pointer, the tip of the mouse gets within 10 units of the center of an area of the screen, the icon changes. Okay, so the center of the object I'm focused on here is at those coordinates. And I know that the coordinates of the mouse pointer are these values here. So my question is it close enough? Is that more than 10 units, in which case the answer is no? Or is it less than 10 units, in which case the answer is yes? Well, this is going to be a pretty straightforward application of our formula. We're going to do the difference of the x values, 114 minus 112, plus the difference of the y values, 80 minus 83. Square that, take the square root, that's our distance. So what do I have here? 114 minus 112 is 2. 2 squared is 4. Over here I've got 3 squared, that's 9. So this is the square root of 4 plus 9. That's the square root of 13. Now you can go to your calculator if you like, figure out what that is. You really don't need to. My only question here, I don't need to actually find the distance. I only need to know if the distance is less than 10 or greater than 10. Well, square root of 13 is between the square root of 9 and the square root of 16. It's between 3 and 4. So I don't know exactly what it is numerically, but what I do know is that it's a whole lot less than 10. And that's all I need to know to answer my question. So the answer is, what was the question? Is it close enough? Yes. At that point, it is close enough that the operating system should make a change. Okay, so now that we've seen some examples of our new distance formula in action, in the next lecture, we're going to take this formula and we're going to use it to derive a new formula for the equation of a circle.